All right, everyone. I really appreciate you all joining us for an R&D panel session. Anyone that's willing to, if you move forward, that would be good. But in the end, we're gonna look at a little more detail on the carbon management side of things and looking at the opportunities that are out there. The Lieutenant Governor and our congressional delegation did a good job of expressing the opportunities. It's not about a defensive move for carbon capture in our region. We have the commodity opportunity to use that CO2 synergistically with oil to produce more oil, and then that oil industry produces more electricity demand. So it's a good opportunity, and one of the many that we have facing us, and that's part of what the Lignite research program is focusing on. So our panel today, I'll introduce them each. One at a time. They'll come up and present, and then at the end, the four of them will come up and we'll have a good Q&A with some dynamic exchange. And first up, we have two industry representatives. The first is Bill Sawyer with Elite Clean Energy, and he's the manager for Clean Energy Solutions. And he's been a champion of technology, including identifying coal-based options for generating CO2 needed to enhance the North Dakota oil production, and doing that while generating electricity that's dependable and affordable for everyone. So Bill's going to kick us off and give kind of an overview from a commercial perspective of the carbon management opportunity. And so please help me welcome Bill Sawyer to start things off.
Thank you, Mike. Good afternoon, everyone. Can I get my slides up, please? So we had a great session this morning, just before lunch, that talked a lot about the why of carbon solutions for North Dakota. Why is this important to all of us in the industry, in the state, and take that even further in the nation and globally to find a solution for CO2 management in our industry. I'm going to focus in a little bit more on the why in my brief discussion, and then we're also going to, as a panel, talk about the what and the how. So what are we doing for our carbon solutions projects in North Dakota, and how are we approaching this? So the slide that you see up on the screen right now is our broad vision and strategy for carbon solutions in North Dakota. So you'll see three pillars of that strategy, starting from the far left, an existing plant solution. So how do we keep the existing coal fleet in North Dakota continuing to utilize our lignite resources, continuing to generate affordable, reliable electricity for all of our citizens in North Dakota and our customers. On the far right side, you see the pillar that says new replacement solutions. So how do we develop new technology that can be used for additions to our power supply or replacement of aging facilities in our power supply? And in the middle, what you see is what ties those solutions together. So the middle is, once you capture the CO2 from either the project on the left or the right, you need to be able to have an opportunity to utilize that CO2 or to permanently store that CO2. So the programs in the middle, you see EOR partners, so oil partners that would take the CO2 from these projects and use them for enhanced oil recovery, or the sequestration or permanent storage options, the Carbon Safe program, and the P-Corps program, both being managed by the EERC. So I'm going to focus in a little bit on Project Tundra, which is our existing plant solution. And then Mr. Matt Greek is going to focus on the ALLAM cycle work, our new technology solution. And we've got Mr. Wes Peck, Mr. Jason Laum from the EERC. They're going to focus in on the how are we approaching those two projects from a development perspective of the technology, and how are we going to look to utilize that CO2 or store that CO2 in the Carbon Safe program. So why are we all here? We heard a lot about this morning, really good summation on why this is important for us in this industry and in North Dakota. Carbon solutions are strategic to us in North Dakota. You heard the words all of the above energy strategy used this morning. Keeping coal in the game, keeping coal as a viable resource in North Dakota and in the industry across the United States is critical for us. We need that base load generation to support our everyday needs and use of electricity. So a carbon solution allows us to continue to use the most abundant fuel in the United States, which is coal. And it allows us to continue to have a platform for energy security and energy dominance. You heard those words this morning as well from Senator Heidkamp, in that energy security is using what we already have, using the resources that we have right here in our state to continue to generate electricity. Energy dominance is using the resources in our country instead of importing those resources in when we start talking about oil and producing more oil from enhanced oil recovery. And carbon solutions projects also help us to maintain the viability of the existing fleets. How do we keep our coal plants in North Dakota continuing to operate in a carbon constrained world? And beyond that, looking more globally, provide solutions that can be used and adopted not only in the US, but across the world for carbon capture in other countries. Let's look at the energy landscape, and we heard a bit about this from the Lieutenant Governor this morning. We have a lot of coal, we have a lot of natural gas in this country. These are some numbers from a couple of years ago. The EIA predicted that we have about a 350-year supply of coal in this country and about a 90-year supply of natural gas available to us to continue to use. Focus in a bit on North Dakota, everyone here in this state. What do we know? We know we have a lot of coal. We know we have an 800-year supply of lignite in North Dakota. You see it behind me, you see it on the front of the podium. 800 years of energy, let's unlock this potential. 25 billion tons of lignite that we can recover, that we can continue to use for affordable electricity. Many lignite plants in our existing fleet, and great opportunities in the western part of the state for utilization of CO2 that we would capture from these projects to enhance oil recovery, to produce additional oil that cannot be tapped right now. We can't get at these oil resources with the conventional way that we produce oil. We need this CO2 to enhance that oil recovery, to be able to get more oil out of those formations. So what does this look like in terms of a project, like a Project Tundra? So this is a roadmap that would show you what we're looking at for Project Tundra as we look at all the components that we need to develop to make this project successful. And I'm gonna click 3 times because there's 3 boxes on this slide. There's 3 key components to one of these projects. You have to have the technology that's available to capture the CO2. So what do you put on the back end of an existing power plant, or what's the new platform for power generation that allows you to efficiently capture CO2? Number 2 is you need a way to transport that CO2 from where you capture it to where you're going to utilize it, or where you're going to sequester that CO2. So you need the pipeline capability to transport that CO2 to the oil fields in western North Dakota. And number 3 is those oil fields, and the proximity of those fields to all of our lignite facilities in North Dakota. These 3 components in terms of the development outlook for Project Tundra. So Project Tundra is an existing plant retrofit at Minnekota's Young Station, where we're looking to add carbon capture at that plant and transport that CO2 to the oil fields in western North Dakota for enhanced oil recovery. So in the development of that project, in this year, 2018, we were fortunate with the tremendous state and federal support that we have to get some funding from the state, get some funding from the federal government through the Department of Energy, and couple that funding with funding from the project partners that are involved to do work across this entire spectrum of the integrated Project Tundra. So we're doing an initial design of the carbon capture system at the power plant in that box number 1. We're looking at what the outlook would be for transportation pipeline, that box number 2, to get the CO2 to western North Dakota, while at the same time our oil partner is doing the design of what's needed in the oil field to be able to utilize this CO2 for enhanced oil recovery. So I said there's 3 key things that's needed to make one of these projects successful. Why is there a number 4 on this slide? Well, number 4 is what we all know, what we've heard this morning, and what I've mentioned a few times. You need dedicated and strong partners that are willing to continue to develop these projects, be able to commit resources like the state has done, like the DOE has done through our federal delegation, to make sure this technology continues to move forward, gets developed, is economical, is affordable for our customers from the electric utility perspective, and also allows us to tap into not only the lignite resource that we're also concerned about, but the additional oil potential in North Dakota. So number 4 is a real big one on these projects. North Dakota is a state of opportunity. You heard me mention the proximity of the coal facilities to the oil resources in western North Dakota. I'm going to click a few times so you see the circles come up here. That's the outlook in North Dakota. We've got all of the lignite facilities within close proximity in the center part of the state, just north and west of us here in Bismarck. And you've got all of these oil resources to the west that could utilize CO2 to enhance their production. So you link those together with an integrated solution. Project Tundra for the existing plant, ALLAM cycle for a new power plant addition to the fleet, and here's your opportunity. Here's the economic viability that was talked about this morning when we say we need to make this technology and these projects commercially viable. It's putting all of those 3 boxes together, making sure you have the technology, you can transport the CO2, and that CO2 can be utilized for enhanced oil recovery. And how's that done? That's done right here. That's done through partners. These are the partners that are involved in the projects across the spectrum that you saw on the front slide, the first slide of this presentation. So it involves industry partners, utilities in the state. It involves our government partners from the Lignite Energy Council to the state of North Dakota, to the Department of Energy, and it involves our partners at the EERC on the research side to help us continue to develop this technology in an efficient way with the technology providers on the bottom of the slide that are actually the ones that own the technology that we would be implementing. So that's what I had for you here today. I'm going to turn it over to Mike, who will introduce Matt.
Thank you, Bill. And next up, to give more of the commercial perspective and talk a little about the ALLAM cycle, we've asked Matt Greek to come up. He's with Basin Electric, and he's the Senior Vice President of Research and Development and Technology for Basin. And he brings with him also expertise on energy generation, efficiency, and engineering side of things, as well as Basin Electric has, again, the U.S.'s only coal-to-syn fuels plant, which happens to have among its many products CO2 for enhanced oil recovery. So he brings a unique perspective on that side as well. So we've asked Matt to come up and give a few words about that and next generation power cycles. So help me welcome Matt Greek.
Thanks, Mike. Thanks, Mike. Well, appreciate the opportunity to visit with you today. I may talk just a little bit about Basin and what we're doing in research, development, and technology, and then I want to spend just a little bit of time talking about advanced cycles, as Bill and Mike said that I would. In terms of Basin Electric, I think most of you probably know we're a relatively diverse utility, although the reality is we get most of our megawatt hours from coal and lignite here in North Dakota and in Wyoming. At the same time, when it comes to research and development, it's helpful, I think, for us to look forward and say, well, what's your future view? If you're going to do research and development, you want to allow some time for that to mature and get to a commercially available scale before you start saying, well, I think I can take this and do something productive with it. So it's helpful to have a view of the future that informs you about where you want to be when you're trying to envision what your research and development work is. So we sit here today, as I said, a relatively diverse utility. We've got a substantial amount of investment and our livelihood tied to coal generation. And we also have wind, we also have natural gas-fired capacity. Of course, we have hydro that comes back to us through our members. But even as diverse as that is, I don't believe that we are coalescing on a view that says that is as diverse as it will be. So you look forward to whatever time frame you think is logical for a future view. And what we would see, I think, is an evolving vision that says, all right, you're probably likely to have other things. We have a small nuclear presence in our portfolio now. Hard to look forward and see what the future of nuclear is in this country, kind of given the challenging economics that we have out there now, driven both by low natural gas prices and the federal subsidies that go with wind. But you can certainly envision a reality where that wouldn't be the case, and it could be important to have nuclear as an option. So one of the options that we include in our research and development work is that future nuclear option. I mentioned kind of renewables and PTCs, but we don't necessarily envision that there's always going to be the level of social engineering that I think we've seen in our electric supply business. We are a capitalist society. I tend to be an optimist and think we will forever get back to that. Whether or not we ever really do is a question for others maybe to answer. But the reality is that I think we'll get to a point where renewables will have to stand on their own in order to be a part of the asset mix. But I'm also a believer enough in science and progress that I believe that's true. As long as we see a value proposition in those things, whether it's wind or solar or whatever your renewable of choice is, the opportunities in front of us to mature those in a way that they can be a competitive option in the future. You know, as part of that, of course, there's a lot of dialogue out there, and you heard this morning a conversation about electric vehicles. There's a lot of dialogue out there about battery technology and storage, and how can we use battery technology to create a storage option. Well, sitting here today, you know, batteries obviously aren't economically competitive with other options that we have out there. There are both technological and, I think, business economic things that kind of get in the way of that. But again, you look to the future and you ask yourself, can those problems be solved? Can those barriers be knocked down? Can those walls be climbed? I think the answer is absolutely. So we think there's certainly a possibility that storage will be a significant and meaningful competitive opportunity for the cooperative in years to come. So I've kind of talked about several things there. Maybe one other thing, we touched on Dakota gasification, the synfuels plant. Obviously that makes us a little bit unique. So not only do we focus on the future relative to generation and transmission, which is our primary business of Basin, we also focus on what are the opportunities that we see for that business that we have, that synfuels business that we have. And of course, when it was originally conceived and built, it was a lignite to synthetic gas conversion plant with the intention of taking that syngas to natural gas and creating a natural gas supply that at that time, you go back to the 70s, at that time we believed was very limited and soon to be unavailable. Obviously that's changed over the years. You know, we've learned to explore tight oil, we've learned to extract very efficiently gas and oil from those tight oil reservoirs, and that has really changed certainly the immediate forecast of where we are and the reality that we see in the oil and gas business. As part of that, we have migrated that facility to do a lot more than just make synthetic natural gas. At last count, I think we had 13 products that we made, or byproducts that we made at that facility, and we've just recently added the last 3 of those with DEF, urea, and compressed CO2. So we continue to see opportunities and explore opportunities to advance that facility as well. So that's kind of another piece of our future view. Well, that kind of covers most everything I would talk about there except for coal. So let me talk a little bit about coal. So there's probably two features to coal, or 2 aspects to coal relative to research and development there at Basin. One is the future view, and we'll talk just about that in a second, and that's kind of the advanced cycles and other opportunities. But the other piece of that is the here and the now. So we have, as I mentioned, a solid foundation of coal. It tends to be the biggest part of what pays the bills, and we look for that to continue for a number of years to come. What's our opportunity there? Well, obviously a lot of our assets, as with others, have a bit of age to them. And because of that, the technology that they use has a little bit of age to it. And so one of the opportunities is, have we had advances in the technological arena, or do we see them on the horizon that we can extract and figure out a way to apply to our facilities to get additional value, to improve their overall competitiveness, to help them be more successful between here and that new future reality. So there's a set of work that we presume to do that's looking to address that and take advantage of that. So that kind of gets us down to the last one, which is the advanced cycles for coal. And when I was in school, I studied thermodynamics. That was kind of my thing. I seem to like that more than anything else. And so I appreciate the opportunity that you guys left me to talk about advanced cycles. I don't appreciate that there are PhDs in the room who will surely be able to correct me, but I'll get over that. The reality of the ALLAM cycle is that it is an advanced cycle. It's primarily a supercritical CO2 cycle. And you might say, well, what's the point of a supercritical CO2 cycle, and what is that thing anyway? Well, if you're familiar with the power plants that we use, at least the coal-fired power plants that we use, they use a basic steam cycle to generate electricity. We heat water up, we turn it into steam, we run it at high pressures and temperatures, and we run it through a turbine, expand it, and then we push it through a condenser to condense it and back into water, and we pump it and start the cycle all over again. The thing that makes CO2 attractive is that it runs a similar cycle. The difference is we don't go through a phase change. And what I mean by that is we don't go from water to steam or steam to water. We stay in a gaseous state throughout the whole process. And that's meaningful because if you know anything about kind of the thermodynamics of CO2 and water, you know that there's a lot of energy differential in that phase change, and you'd like not to go through that. You'd like not to waste that. And a lot of one of my thermal professors used to tell me, all your sins go to the condenser, and it was his way of saying that anything you didn't effectively extract for good work in the cycle, you have to discharge, you have to throw it away, and the condenser is where you throw everything away. Well, we don't want to throw anything away. We want a super efficient cycle. CO2, high pressure CO2, supercritical CO2, gives us that opportunity to do that. And so it becomes very attractive to us. Now, it's even more attractive to us today because we use an oxy-fired system on the front end of that, which means that essentially we create a pure CO2 stream, or nearly pure CO2 stream, as part of the process, as opposed to generating flue gas, which has CO2 in it, but has a number of other constituencies as well. That pure CO2 stream then gives us other opportunities for the use of CO2. So we look at that as an opportunity to participate in EOR or sequestration. We get the added benefit that the CO2 discharges at supercritical pressures, and so you're not having to go through a second compression step to sequester it. Now, most of you probably know that we do enhanced oil recovery from DGC up in Canada. We produce CO2 as part of the operations of the facility, but we have to compress that CO2 in order to get it up to Canada and make it available for enhanced oil recovery. Well, that's an expensive process. We'd like not to have to do that. The ALLAM cycle and other supercritical CO2 cycles offer us that opportunity to avoid doing that. So those are kind of the primary reasons that we've spent time looking at ALLAM cycle. In terms of the overall development of it, these guys may talk a little bit more about that. We can certainly answer your questions. But it continues to be an area of interest. We do look at other supercritical CO2 cycles. It's not just ALLAM. ALLAM happens to be the one that we've been most involved in here over the last few years. So with that, I'll turn it back over to Mike, and we'll be back in a minute.
Next up, we have Wes Peck, and not only is Wes a geologist like many of you are, he leads the geosciences group at the EERC, so I told him yesterday every time he presents I learn new words for Scrabble, the geology words, as well as I learn about geologic time. So Wes is, he's looking at different parts of the geology since the beginning of the Plain CO2 Reduction Partnership, which has gotten a lot of this confidence in our geology in the region. Wes has been involved. And now he's working on the Carbon Safe project that's part of North Dakota, where you heard about the wells drilled in Oliver and Mercer County. So Wes is going to come up and give you an update on that project and the scope of it and the status, as well as talk about some of the other opportunities we have in our geology for storage and best of all utilization of CO2. So please help me welcome Wes Peck.
Thanks, Mike. Well, you really can't see anybody, can you? All right, thanks, Mike. I'm from the ERC. Many of you folks are quite familiar with the ERC and what we do there and how we've been proud to be part of the investigation to help promote coal in North Dakota for a number of years and hopefully to go forward in doing that in the future. We approach that very seriously, whether it's from Jason, who will come up next and talk about on the power plant side, or myself in the subsurface. But we pretty much have this mentality every day. This is how we intend to approach a lot of what we do, and it is how we move forward with making sure that we can provide the best solutions possible. And we like what we do, so there might be a little tongue-in-cheekness to this, but this is really behind how we move forward. So I'm going to talk a little bit about Carbon Safe. Mike introduced that. It's a project that has been going on now for about 10 months in North Dakota. It's funded by the Department of Energy primarily, but with support from the state to the Lignite research program, and with additional support from our partners. And we're looking at the technical and non-technical challenges associated with the deployment of CO2 storage in central North Dakota in the coal country, and to hopefully develop a certified storage container that could be used if the economics and business case behind it can support that. And this photo here, just another spring day in North Dakota, apparently, as we noticed this morning. This is the well that's being drilled, or was being drilled, out south of Center, a couple of miles. So here's the list of our partners, all great partners to have as part of this project, from the coal mining side, the power generation side. Like I say, our number one on top for money-wise was the Department of Energy for supporting this, and of course the Industrial Commission and the Lignite Research Program. So we're looking at two ideal geologic storage areas, one in the area around Antelope Valley Station and the other near Milton R. Young Station. As you know and as have heard, one of them has a readily supply of CO2 that's currently on its way to Canada to be utilized in EOR, and the other, as Bill had mentioned, is planned as part of Project Tundra for additional CO2 source. Also looking at gauging public support. As you know, that without a public behind you in a positive fashion, things can go very poorly or be interrupted completely. And then the regulatory and economic aspect of it, we're investigating to make sure that the state has the appropriate tools in place to oversee such a project, and that the economics really work out so they can move forward in the best way possible. North Dakota's got a lot of advantages over the rest of the states looking at this type of thing. You can see that the Class 6 primacy, which North Dakota has applied for, has been notified that it will receive. And most recently, I heard from Lynn Holmes at the Industrial Commission that the permit will be in our hands somewhere between 3 weeks and 3 months is the timeline he gave, but he's been informed that it is on its way, the official paperwork for it, to give us the first Class 6 primacy of other states. The pipeline we spoke about, the long-term pore space ownership laws and long-term liability laws that have been put into place over the past number of years also set North Dakota apart from many of the other states in the country. We were the template for Wyoming as they move forward to try to do that. So we have a lot of advantages to making this work in North Dakota. Point out the two main components of this. One was the hopefully the CO2 that would be moving from Milton R. Young through the Project Tundra, and the other is if there was a decision to move any CO2 from the pipeline that goes to Weyburn, if with the 45Q tax credits, if that's an advantage to take it to pursue, that will be the other source of potential CO2 in this scenario. Bill had already introduced this, but we are the CO2 sequestration component of this diagram, circled in red there towards the bottom of the image. Not looking in this particular project at the details of EOR out west, that's in another project. So we've drilled the 2 wells, the one near Golden Valley, North Dakota, and the one near Center. There have been drilled, plugged, and abandoned. They're all closed up. The idea was never to keep them open indefinitely or use them as monitoring wells. We were purely after more knowledge of the subsurface. We took 300 and some feet of core from each well. The formation that we were targeting is called the Broom Creek Formation. Those of you who are savvy in the ways of the subsurface also have heard it called the Menalusa. We did a lot of geophysical logging to tie it into pre-existing data, and we had purchased some existing 3D seismic that was in this area, so we can tie our new data to some legacy data. So this is a picture of a piece of the core that came out of the well near Golden Valley, North Dakota. This is a beautiful chunk of sandstone, and there's close to 200 feet of this sandstone in that 300-foot section. Fluids would flow readily into this formation, whether it be CO2 or otherwise. So this is a very promising formation for the storage of CO2. This pile of sand shows some of the, is an example of how some of the material came out of the ground. This is from the well near Center, North Dakota. It had a number of feet of sand that was like the previous photo, but we also encountered sand that was very poorly consolidated. It came out in the core barrel as if someone had just shoveled it into there. So very good properties for fluids to move into for the injection of CO2. Looking forward then as how to implement the Class 6 primacy in North Dakota for a particular storage project that might arise. We're pursuing that, working closely with the Industrial Department and the Industrial Commission on how to make sure those rules are followed. Looking at site access agreement, pore space acquisition models for amalgamating land, landowner compensation for storing CO2, and then looking at some of the economic balances and how they might play out in the storage scenario. And again, this is all the non-EOR side. Moving forward to some of the other projects, trying to synergize North Dakota's industries. We have 2 giant pillars that we're focused on. One is the coal mining and electrical generation side, and the other is our oil production side. And then linking them together, as was mentioned, through the CO2 aspect. So we have the big pipeline running up through the middle of the state. It touches many of the oil fields that are very amenable to CO2 EOR. And there's a bunch of other oil fields you can see down to the south and southwest corner of the state. All of those also, these are the top oil fields. There are those that are the next tier down that would be ready for CO2 EOR also. So millions of incremental barrels and millions of tons of storage opportunity simultaneously. So one of the things we've done is look at some of the bulk economics, and I'll try to get advanced through the animation in here. But we're looking at the inputs and outputs from enhanced oil recovery, looking at the inputs and outputs from the coal generation, electrical generation, and how this could then feed more into state revenues and start to drive the synergy between the 2 industries. And the numbers that are up here right now are super preliminary. We're looking at to improve upon them and then focused in on individual point-to-point type economics. It's been discussed numerous times at the meeting, the rare earth element aspect of coal. It's something that does have a potential for exploding into a different utilization of the coal resource in addition to making electricity. The concept of carbon to graphene, kind of a space-age material, if there's a potential for that, that would be awesome to have here. Activated carbon, and as you can see, carbon fiber, cobalt, other potential off products from the mining of coal. We're working with the Institute for Energy Studies up at UND and the North Dakota Geological Survey on the rare earth elements component of it, along with Kentucky Geological Survey and Eastern part of the United States to look at how we could assess the amount of rare earth elements in the coal, and then also how do you get it out of the coal. Skip over that one. One last little quote though, and then this is a very important part of what we do and why we're here today, and basically the bulk underlying premise for the entire meeting like this, and that is to educate those within our community, industrial community, with our greater living community, because it's that education and putting the word out there that really makes what we do have some meaning, and that helps push, whether it's from a state or federal side, helps push legislation and understanding of what can be done to promote and continue the lifestyle that we've become very much accustomed to. So we have photos here bringing the kids from Center, North Dakota out to the drilling site and introduced them to the concepts of deep subsurface exploration. We talked about the concepts of carbon capture, about coal utilization through our P-Corps program that has been running for the last 13 years or so. We put out a lot of public outreach material, and then the more that we can get out, the more we can share the word and show the importance and significance of what we're doing, the easier it is to move forward. So that's what I have for now.
Thank you, Wes. And our anchor panelist originally hails from Berthold, North Dakota. It's Jason Laum of the EERC. And Jason is the coal utilization group lead, and he's also the project manager for two of the projects, Project Carbon, which is a precursor to the Project Tundra opportunity, and then the supercritical CO2 cycle work that we refer to as the ALLAM cycle. And so Jason's going to present you with the scope of those projects and update on where we're at. And then after that, we'll do the question and answer and get a good dynamic exchange going. So please help me welcome Jason Laum.
All right, thanks, Mike. It's a pleasure to be here, and Wes, savvy in the ways of the subsurface. That's great. I cannot think of a brilliant way to describe engineers. I'm sorry, I really can't. But I will share a quote that I saw several years ago, and this was a representative of some state in Congress. I won't say what state it was. But why are we using all of these fossil fuels to produce power? Why don't we just use natural gas to do this? You know, and I shuddered when I heard that comment. That, you know, think about it, natural gas, because that's not a fossil fuel. I think this person has been re-educated, and Wes brought up some good points about education, and that is a very important aspect of what we do at the ERC, is try and get out and educate the public on what it is we're doing and what it means for them. Bill Sawyer did an excellent job. You saw the slide earlier. Wes just got done talking about the R&D that we have going on in the middle portion of this graphic, and the two end members. I am going to use a geological term, though, Wes. The Project Tundra and the ALLAM cycle work. I'm going to talk about the R&D efforts we have going on to support those efforts. So I'm going to start with the ALLAM cycle project first. Matt did an excellent job of describing why we care about supercritical CO2 cycles, why they're more efficient. This is the team of folks that is working on this program. On the left-hand side of this graphic, you see the team that's working on the natural gas demonstration of this technology down in LaPorte, Texas. That's a 25 megawatt electric demo plant. On the center is the coal-fired ALLAM cycle team that's been looking at lignite and the specific areas that we've been working on in our project, looking at what gasifier is going to be best for this technology, what is going to happen with corrosion and impurity removal, and I'll tell you why that's important here coming up. So what is the ALLAM cycle? Like I said, Matt did a good job of telling you what the ALLAM cycle is. It is a direct fired CO2, supercritical CO2 cycle. So what does that mean? It means that the coal is gasified, similar to what is done at DGC, and that syngas that is produced is then fired in an oxy-combustion mode. So you have to have enriched air or oxygen CO2 mixture to keep the impurities down. And that creates a stream of nearly pure CO2 that gets run through a turbine. And at the end of the cycle, the CO2 is exhausted at pressure, which is really important for those of you that want to use the CO2 to do something in enhanced oil recovery, or to put the CO2 in the ground like Wes talked about with the carbon safe. So the key areas to mitigate that we are focusing on with our ALLAM cycle project, the metallurgy and corrosion. As you can imagine, when we have something at high temperatures, high pressure, and you throw in a bunch of acid gases, there's a potential for corrosion to happen. We looked at several materials, and we looked at several ways to clean the gas up, and I'll go through some of those details here. The other aspect is gasifier selection. Those of you that have gasified or combusted lignite know that it has some unique properties. I guess that's a way of saying it can be challenging to utilize. So we looked at a suite of gasifiers and determined, well, which one is going to work best for this power cycle. The folks at Dakota Gas use Lurgy fixed bed dry bottom gasifiers. Is that the best gasifier for us to consider for this cycle? Probably not. So we opened the net and looked at other commercially available systems. Gas cleanup. How do we scrub all of the impurities out of those gases? The acid gases, the particulate matter, looking at some advanced technologies, and even looking at some existing technologies that are more commercial, something that you could pull off the shelf and plug right into the cycle. And then the other thing that we're looking at is a syngas combustor design. As you can imagine, combusting syngas or even the natural gas like they're doing down in Texas, high temperatures and pressures, is going to require a specially designed syngas combustor. We're still trying to get the funding for this portion of the work, but we're looking very, very closely at what is being done in LaPorte with the natural gas case, and communicating with the folks at that plant in Texas, and trying to learn as much as we can about that demonstration. And that system is going to be firing up here very, very soon in April and May. So what risk have we brought down? What does this project produce, the results to date? We have found that materials exist that can withstand the temperatures, pressures, and these acidic environments created by the ALLAM cycle, and they are not too obnoxiously priced. One of the materials that we have found that will constitute a lot of the system is 316 stainless steel for a lot of it. Some of the more advanced materials, like a 740H, that is being used right now in ultra supercritical boilers. So these materials are available and are out there, and the entire cycle does not need to be made out of some supermithium material that doesn't exist. That's a very important part that we found, and we did the test in a dynamic fashion. What do I mean by that? We had constructed a vessel and some pumps, and we were actually flowing the acid gas and CO2 mixture across these coupons, so that surface was being refreshed with new reactants the whole time. Not a very easy thing to do, and we're pretty proud of the system that we made. We believe it's one of a kind in the country, if not the world, to be able to do this work, so we're pretty proud of that. Gasification, which platforms will gasify lignite for the cycle in the best manner? We looked at 3 of them. We narrowed it down to 3. The ECUS system, the Synthesis Energy System, and the British Gas Lurgy. And we moved forward with the ECUS and the SES systems to do a more detailed engineering study to look at what would an ALLAM cycle plant look like with these 2 main gasifier systems. And right now we're just putting the finishing touches on a costing study, look at feasibility level cost estimate of what it would take to build an ALLAM cycle with those gasifiers and with some existing cleanup technologies. We tested a post-combustion removal process for removing the acid gases. What we found, it's pH dependent and it requires a lot of water. We also found that the post-combustion technology that we tested, called the DSNOx technology, is likely going to require some upfront removal. We did find that concentrated acids did exist and could create some problems and some challenges if one went with just the post-combustion cleanup. So there are technologies exist to combat this, but it was a key finding from the post-combustion testing. Syngas combustor, I already talked about that. There is a design for a syngas combustor that has been done by our project partners, and we are looking forward to testing that design here. Everything in this world comes down to dollars and cents. So what does this mean? The two blue box plots that you see in the middle there, those are the first of a kind ALLAM cycle on natural gas and the first of a kind ALLAM cycle natural gas net power, and on the bottom, the ALLAM cycle coal. So you can see that those initial LCOE estimates are on par with other technologies that are pursuing carbon capture. For example, IGCC and supercritical pulverized coal with a post-combustion system. So we're very excited about these numbers, and we are updating these numbers, as I'd mentioned, and they're not quite ready for public dissemination, but they'll be coming out very, very soon. So now I'm going to switch gears a little bit. I'm going to talk about a project called Project Carbon. Project Carbon is a project that is being done in support of Project Tundra. A lot of you know and have heard about Project Tundra, and these are the folks that are working on this project and the folks that are representing each entity. Mike Holmes from the state of North Dakota, Elite being represented by Bill Sawyer, Minnesota Power, Stacy Dahl and Craig Bleth on the technical side representing Minnesota Power, Mitsubishi Heavy Industries, the MHI post-combustion technology, the same one that's at Petronova is a technology that we're looking at. Ron Bryant from Burns McDonnell, the owner's engineer, and then myself from ERC as a project manager. It's a very diverse team, and it takes a diverse team to take a look at this issue. How was Project Carbon connected to Project Tundra? People ask me this all the time, and I think this bubble diagram does a good job of showing how it is connected. Project Carbon, represented by the dashed circle in the middle, is really two individual projects funded by the team that I previously mentioned and the U.S. Department of Energy. All told, Project Carbon is around $12.7 million in funding with all the entities. And it's looking at the final barriers to implementing CO2 capture at the Young Station. And Wes was talking about Carbon Safe. Well, Carbon Safe could be part of what would be considered a Project Tundra. You can see Carbon Safe represented on the CO2 storage side by the bubble on the bottom. The other components of Project Tundra are the CO2 infrastructure and the field site connection. And those important parts of Tundra are being looked at in other projects. But this just gives you an overall idea of how the projects are connected. So what is the goal of Project Carbon? I'd mentioned addressing those critical barriers, fill in those final data gaps to install a post-combustion CO2 capture facility, specifically looking at the Milton R. Young Station, more specifically Unit 2. We need to determine the capture efficiency with the MHI solvent. MHI has the KS1 solvent that we're looking at that was used at the Petronova project, but they also have a new solvent that we're looking at, and we're really excited to see how that particular technology performs. We're going to be doing some tests with our capture system that I'll talk about a little bit later. We're going to be doing a thorough economic analysis. We're going to be doing a pre-feed study, taking those results that we get, and Burns McDonnell and MHI are going to give us a pre-feed level cost estimate of what it would take to implement post-combustion capture. So in more detail, the focus on the right-hand side of this slide, you can see our capture system that we have at the EERC. And I'd mentioned we're going to be looking at those amine solvents, the KS1 and the advanced amine. We're going to be, we've already started some of these test campaigns. We started with a very standard solvent, monoethanolamine, MEA. Many of you know that solvent like that. We started these campaigns at the ERC within the last 2 to 3 weeks. We're starting to get some good results, shaking down our capture system, and then we're going to be taking the same capture system that we use at the ERC in controlled combustion conditions, and we'll be taking it out to the Young station, and we'll be installing it in slipstream configuration. We'll be getting very valuable data on the actual flue gas that would be supplying a project such as Project Tundra with the CO2. We're going to be looking at the economics of the carbon capture. We're going to be looking at the differences in all the different solvents that we're going to be testing, looking at the advanced solvent from MHI and their standard solvent. One of the other challenges that we're going to be addressing, there's been a lot of talk about aerosols and how some of the aerosols that might be formed when one combusted lignite, how that might impact a carbon capture system. So we're going to be looking at that as well, and we're going to be looking at some mitigation strategies. We've designed an AERU unit that we have put on the tail end of our capture system, and initial data says that it's reducing the number of aerosols that come out of the AERU. So more to come there, but it's looking very promising. And then the pre-feed analysis. We're going to sit down, roll up our sleeves with the team, and we're going to determine a design basis for the Young station. Do you look at capturing all of the CO2? Do you look at a fractional capture strategy that Charlie had mentioned and asked a question about this morning? So we're deep in that right now, and we're looking at those things, and we'll be generating flow diagrams and utility demands for that, and all leading to a cost estimate. And this is very valuable to North Dakota. If the results of Project Carbon are positive, people have asked me, well, what are the next steps? Well, the next steps are this information is given to the Project Tundra team, and if everything looks positive, they continue on down their development path for Project Tundra. And if Project Tundra becomes a reality, it can be applicable to many of the other coal-fired facilities in North Dakota, which means to us, keeping the current lignite industry, and we all know how valuable that will be. At the same time, it could create a new enhanced oil recovery industry, and this means hundreds, if not thousands, of new jobs in an area of the state that could use a few more jobs right now, which also means new tax revenue, not just from income taxes and things such as that, but more oil produced means more production tax on the oil. We think that we can leverage some of the successes learned at Petronova, which we, as a project team, feel will really reduce the cost of this. I wouldn't want to say nth of a kind, but if N is number 2, the second plant that would use this MHI technology. So we're feeling that there's going to be some cost reductions realized, and looking at 45Q legislation and how tax credits could be used could be very exciting. So that's what I had for you all, and look forward to answering some more questions.
Well, thank you to all our panelists, and now they're going to come up here, and it's a chance for you all to ask them questions and get some additional information or details, and any comments also from the group in the audience would be appreciated. So do we have any start-off questions? Or?
It's your chair there on the end.
Oh, thanks. Do we have any to kick it off, or do you want me to start? Or? All right, well, we're waiting for the first question from the audience. The next thing I'm going to hit them up with, because we often talk about the capture technology, the utilization and storage. In the state, we have expertise because of the DGC plant for transportation and compression and that. And if you look at the DGC pipeline, it goes right up through, in the map Bill Sawyer showed, it goes right up through some of those conventional oil opportunities. So the question is, what do we need to do for the next infrastructure in the state? And is it a single project by single project basis, or do we need to think ahead and look at the Bakken future as well and find ways to get down to the southwest part of the state as well as some of the other locations? So anyone want to take that on?
Sure, Mike.
All right.
I'll start with an answer and others can add to it. I would say it's a great question and it's a fair question for where we stand today. So we have a valuable opportunity in front of us with a number of lignite facilities that are in close proximity to each other and a number of opportunities that we have in western North Dakota on enhanced oil recovery. So how do we use that to everyone's benefit in the state of North Dakota? We need to look at a solution that would allow, yes, a single project to be built because someone has to be the first to build the project, but also be able to leverage the possibility of adding on additional projects. So looking at a broad-based infrastructure solution for the state that could have maybe a corridor where a pipe or pipes for transportation of CO2 could be placed that could be utilized for the first project, but either have the capability from the design to add more capacity to that pipeline, or to have at least looked at what corridor or corridors are possible to design and build additional infrastructure. So really take a look at it at the very beginning on a holistic state view for all of the potential sources and all of the potential uses in the state.
Okay. Any other additions or questions? Any questions? Yeah, Steve.
North Dakota buy my electricity from MDU, and of course nobody knows what you pay for electricity. They know what you pay for gas, $2.59 a gallon. So I called up MDU and they said, hey, you pay 7.6 cents per kilowatt, which is darn cheap. So my question has to do with economics, and I know everybody up here that said, you know, we've run some numbers, but you know, they're not ready for prime time or whatever it was. But I just want to know, what's going to happen to my bill when we buy electricity from a power plant that is capturing CO2? And you can, you know, tell me what it is if you used carbon safe. You can tell me what it is if you used EOR or whatever. But I want to know what's going to happen to the consumer's bill when we start using CO2 capture, CO2 storage or utilization or whatever. What's going to happen?
I can take a crack at that. So there is a cost to capturing CO2. There is a cost to pushing it downhole for sequestration or for EOR. Obviously, if you're sequestering it, you're not getting a return other than 45Q was mentioned, so there are some federal subsidies, if you will, that are available to support sequestration now. On the EOR side, obviously, there's a potential to get a piece of revenue that comes from the additional oil production from the field that comes as a result of pressurizing it. So the answer to your question is a pretty complicated one, depending upon what you get in return for capturing the CO2. If you're just capturing it and you're sequestering it, and you're not getting any compensation for it, then it's going to push the bill up. How much? You know, I can't do that math in my head, but it would be meaningful. It would be something that we would notice, and that's one of the reasons that I think you see Basin and others are active in the discussion, both at the state level and the national level, when it comes to considering those kinds of rules and regulations, right? So where you're really exposed to that is where we come out with a rule that says, this much CO2 will be captured from, this subset of facilities, and it will be done by date X. That really limits your opportunities to mitigate the cost of doing that. So there is a cost to it, but I think it's going to widely depend on whether or not it's something that we're able to do based on opportunities and that allow us to offset those costs, or whether it's something that we're mandated to do.
And I'll add to that. Great points that you made there, Matt. And there's a reason, Steve, that we put the slide up that says an integrated solution. It's an integrated solution because the costs that you would spend, the money that you would spend to build out the capture system and the pipeline and what needs to be done in the oil field can be offset by the opportunity of utilizing that CO2 for enhanced oil recovery, or as Matt had mentioned, the possibility of federal tax credits through this 45Q program that would work like a wind production tax credit. So every ton of CO2 that's utilized either for enhanced oil recovery or sequestered would allow a tax credit to the generator of that CO2. So there's ways within the business structure of this integrated project that would allow the project, just like Petronova in Texas, NRG's facility, to be commercially viable, to be able to move forward and try to mitigate, as Matt said, the impact on the electric generation side to electric customers.
All right, well, we're looking for the next question. I'm gonna, oh, we got one here, okay. Well, we're getting the microphone over there. It's a quick question for the R&D side as well as the pre-commercial side. We're talking about either first of a kind or first of a kind on Lignite. So we've got some federal support for projects. For Wes, it's Carbon Safe Phase 2. What are the prospects for Phase 3 funding federally? And Jason, you recently leveraged the supercritical CO2 work. What are the prospects for a year from now? Additional funding on that? Is there something in the pipeline or potential there?
Well, I'll take a first crack at that. With respect to the Carbon Safe program, yeah, we are in the end of the first year of a two-year project with Carbon Safe Phase 2. When the Carbon Safe program was initially outlined, it has 4 phases, and we were able to jumpstart at Phase 2 because we have done so much of our preliminary work with our partners and through the P Corp project that we were easily poised to start at the second square. Right now, we don't know if there's dollars in the most recent federal budget to move ahead with Phase 3. The rumors are that there is money in there, and if that's the case, that may start then in 2019.
Okay.
So, Mike, you'd mentioned on the ALLAM cycle side that we were able to further leverage the existing dollars that we have, and we are in the process right now of finalizing an additional $700,000 award with the Department of Energy on a program that is looking at advanced technologies such as the ALLAM cycle and looking at moving them to a demonstration phase. So right now, upon award, we'll be in Phase 1 of the project, and there were a restricted number of projects chosen, and there's 3 phases to the award, ultimately ending up in a potential for $80 million being available for demonstration. And during each phase, you have to reapply, and the number of technologies is reduced. So there is a mechanism right now on the DOE side to look at a coal-fired ALLAM cycle demonstration facility moving forward, pending positive results from our existing program and the work that's being done down in Texas.
Okay, great, thank you.
Hey guys, just a question. Could you talk a little bit about what really sets what Project Carbon is geared toward doing? What sets that apart from what they're doing at Petronova, what's being done at SAS Power? Because this is really unique, so talk about that a little bit.
Want me to go first? I can go first. So Project Carbon, Project Tundra, as most of you know, there are 2 other post-combustion capture facilities in the U.S. right now: the Petronova project, and then the one up in Canada. Project Carbon is differentiating itself from Petronova as being a fully integrated capture facility. What do I mean by that? Down in Petronova, they brought on an auxiliary boiler, natural gas fired, to provide the steam and the power to run the capture system. We're looking at full steam integration at the Young facility and try and take advantage of as many efficiencies as we possibly can, and differentiate itself from the capture facility up north. It's going to be a lot larger than that facility, and it's going to produce more CO2, and it's a different technology that we think is going to have some more efficiencies because it's the second installation of that technology.
And where's Charlie? I saw him out here earlier. Charlie, we are looking at in our initial design right now the possibility of both a 60% capture of flue gas from Unit 2 at the Young Station and what would be 100% capture, so the 90% option that you asked about earlier. So we're looking at both of those to try to determine the capability of the technology and then how that relates to economics of the project.
All right, the next question is back with Steve, and then we have another one here.
Yeah, this has to do with advanced oil recovery. We have the CO2 pipeline, which runs through the conventional oil fields now, and then since that was built, the Bakken is nearby. But yet we don't have any of the North Dakota oil companies that have actually gone for it and sought to purchase the CO2 and use it for enhanced oil recovery. So I guess I was just kind of wondering, why haven't they, but yet are they expressing interest in doing so at some time?
Well, I'm going to let you touch on the pipeline aspect of it if you want to, but right now oil companies have definitely been interested in CO2 EOR for quite a while. There's a supply and demand aspect in North Dakota where right now the supply has been in the past all going to Weyburn. Contracts to be part of securing some of that CO2. Those discussions have taken place in the past. New interest, though, is certainly taking root in North Dakota with respect to CO2 EOR. There's interest in bringing CO2 from Wyoming into North Dakota, to actually outlay the capital expense of bringing CO2 that distance. Places that are off of the main pipeline route now that goes up through the Nesnanic line, they're interested. So those things in the background have definitely been happening over the number of years, and there may be some synergies and some deals that could come together in the near future to start to see that turn into reality.
Yeah, I wouldn't say there's a lack of interest in doing EOR in North Dakota. It's like anything, you have to get the economics to line up, and with tight oil and kind of the revolution that's occurred there, there are other ways to get oil from other fields that may be more economic than doing EOR. But beyond that, each field kind of has its own reality, and so what works for Weyburn and the CO2 we send up there may not work for other fields, and so there might be cleanup or other things that you'd have to do the CO2, or a different CO2 supply that you'd have to use that would make sense for that particular field. So there is a level of complexity that we really didn't get into today that enters into this, that has to be considered, that has an influence then ultimately on the economics. And at the end of the day, projects get done because they're economical. They don't get done because they're not. And I suspect, where oil prices are coming up a little bit now, and maybe people are getting comfortable they're going to sustain a little higher level, probably will create more conversation. With the 45Q, you've got a kind of another incentive in there that wasn't there before. So I would expect, as Beth indicated, there's going to be a pretty healthy dialogue around EOR opportunities. So I wouldn't say there's not an interest. There just hasn't been a match between the opportunity and the economics.
And just to add to that a little bit, you had asked a question about the Bakken, I believe, as well. And what we're talking about right now in EOR opportunities are some of the older fields, some of the Madison, Mission Canyon type of fields, and to use the CO2 that likes coming out of DGC that might have a little more sulfur in it than one would like. You certainly wouldn't want to use that in the Bakken. That's consideration. The Bakken is a very sulfur deplete field. It's very, very sweet. So just add that.
Yeah, and at the Energy Center there we've had a lot of effort into looking at CO2 in the Bakken, and we're definitely moving forward, maybe not as fast as we'd like to, or others would like us to move forward, but it's definitely a progression in the right direction. And if we can crack that nut, there's not enough CO2 in North Dakota from all the power plants to supply what the Bakken has the potential for.
Okay, and then we had a question over here.
Yeah, Charlie. Simple question, really, and probably tough to answer, but presume the carbon project could go on for a long, long time as solvents evolve. But I'm curious if anyone would want to venture a guess at when West gets CO2 from either of the two projects. When is CO2 delivered? When do you think either project will start delivering CO2, Tundra or the ALLAM project?
Great question, Charlie. In the development phase of both projects, there is more work to be done. So we're doing initial design on Project Tundra. ALLAM Cycle is doing their own initial design and pilot plant at their Texas facility. Then you would move more to the final design. So you got a couple more years of the design and the commercial structure of what's needed to make these projects happen. And then you would move into construction. Construction is going to start with permitting and then construction. So that's another 3, 4, 5 years. So you're talking mid-2020s by the time one of these projects would come online.
The only thing I might add to that is we have had some dialogue. You know, we talked about ALLAM on natural gas, and there has been some dialogue about maybe an early 2020s commercial application, but we haven't seen anything, at least I haven't seen anything that rises to the level of a committed commercial proposal yet. So I think there's a lot of risk around that, back to maybe what Bill was saying. So maybe it feels more like, you know, a safer bet is the mid-2020s or late 2020s that you could see the ALLAM cycle in commercial production here in North Dakota.
Hey, it was just a question on other sources of funding. When I sit and listen, it sounds like a lot of the companies involved are putting forth money. We're relying on the government. What about going after the public for funding? And one of the reasons I bring this up is I have a brother and sister-in-law in San Francisco. And when we talk to them over the holidays, it's very concerning to them because a lot of their friends, the greatest threat and fear they have is global warming and how it's going to destroy the earth. And they actually pay money to plant trees. They spend all sorts of money on the coast to fund these sort of things. And I just think it would be wise if we could reach out and speak their language or some sort of site and say, hey, if you're concerned about CO2 and global warming, and we could give just slight education, we talk their talk, the website looks like them, we're trying to save the world, and give this to a project that can actually take and capture all the CO2 from coal plants and put it in a CO2 prison. I mean, speak their language, raise their money. I really believe there's millions of dollars we could bring in for the research because they do spend a lot of money to support what they believe. It's crazy what they spend for eggs because they want free roaming chickens and what they give to these organizations to protest and save the world because San Francisco is going to flood, and there's a lot of money there, I believe.
Yeah, and that's a tough one to answer, but when you look at the commercial ones like ethanol produced using excess heat, there's a green credit for that, so they get a higher value for their product. So that's one example. A lot of the work being done on evaluating the carbon footprint of oil produced with CO2 EOR is showing that they can name that green oil because it's produced with a lower carbon footprint. And so there are some of those different industries that can get some extra financial benefit out of that type of thing. As far as pooling R&D, that makes it a little harder, I think.
Well, the ethanol plant, Red Trail Energy. They're looking at capture and storage of their CO2, and they want to take advantage of the ethanol market on the West Coast. So the clean air fuel standards that they have out there, the ethanol that they could produce in North Dakota, ship it to the West Coast. So in a way, those people are supporting our activities. That economic benefit that, say, Red Trail Energy could benefit from will drive some of the earliest CO2 in the ground in North Dakota. It will maybe help pave the way for the second, third, and fourth projects, but it is, in a way, a fashion, as you explained, crowdsourcing a project in North Dakota. Here, if the North Dakota ethanol industry can take advantage of West Coast ethanol prices and show that the ethanol producer in North Dakota has a significantly lower carbon footprint, then we'll have taken advantage of their willingness to give dollars.
And the other thing I'd add to that is it also emphasizes what you're saying, emphasizes what others have said this morning, and that is we can always improve messaging too and talk about all the work that has been done and is being done to take care of this, because messaging's part of it too.
Just with the website and setting up PayPal, I mean, no product going there, no logistics, just literally taking their money for research, because we can say, we have projects going, we have research. You're scared, I mean, they're scared the world's gonna end in 10 years. I mean, and the truth is, the more money we get, the quicker it goes, and we can give them results on the website.
I like that idea. All right, any others? The thing that's going through my mind, it might not be a fair question, but when we talk about CO2 capture, we talk about increased demand on energy in the state, in the region. When we talk about enhanced oil recovery, we talk about further increased demand on energy in the state and the region. At one time, when the Bakken was going great guns, the projections of additional electricity need were incredible. By 2032, about a doubling. And then when we talk about producing more oil and gas, the gas processing plants are a big driver for additional energy. So I don't know if anyone wants to address that. Of course, it adds more uncertainty to our commercial side here on the energy side, because you can't build on a projected price of oil and what that might bring, and so you need very responsive energy supply. But some of these things we're talking about to help with the economics of coal through CCUS also could drive the additional need for coal. You could actually regenerate your solvent with an auxiliary coal-fired boiler. So I don't know if I've taken us off track, but any thoughts on that?
I'm not exactly sure what your question was, Mike. That'd be my first thought.
You're ready for that demand.
But I'll go ahead and give you an answer. I don't always have to have a question to give you an answer, right? So, yeah, it's very difficult to project load growth. Obviously, we're in a commodities business, and anybody who's followed commodities understands how volatile they can be over time. About the time you think you've got it dialed in and you know where they're going, they prove you wrong. So yeah, predicting growth is tough, and some of the things we do, you're right, they do generate growth. Somebody asked us one time to look at carbon nanofiber production, and we got looking at carbon nanofiber production, and it increases the power consumption to the point where you don't have any power to output, all you've got is carbon nanofibers, which is fine if that's the business you want to be in, right? But it's an example of some of what you're talking about, where you get started down one path, and you know, the further down the path you get, the more it kind of mushrooms and the more it grows into other areas, and you have to sort of factor those things in as well. We have grown quite a bit in the Bakken. There is a view, I think, that perhaps I share, I don't know about others, but that will become a significant exporter of LNG, will become a significant supplier of gas liquids, both in North Dakota and as a country. And so there's a certain driver, if you will, for the growth of that industry, that really doesn't have anything to do with us. We just happen to be sitting in a position where we'll be the ones to serve it. So I think that's part of, what we have to factor into our calculus, which is where a lot of the nation sits here today and has slow or no growth or even declining growth in the electric power sector. We don't necessarily see that. We certainly haven't seen it. And I don't know that we see that in our forward view either. And that gives us a set of opportunities in terms of what we can do. It also gives us a set of challenges that are in front of us. So I think it's a great topic to talk about. Don't know that I have the exact view of where it's going, but certainly something we spend time on and try to tweak what we're doing to capture that view.
Great, thanks. All right, with that, we're going to wrap up. Please.
Got one more question.
Oh, we got one more. Okay, one last question.
Yes, with regard to EOR, there's been quite a history with EOR. I mean, it started out with acidizing wells, and then it went to water flooding, and eventually progressed to CO2 flooding. I understand now that because of the unavailability of CO2 in North Dakota, that they are actually using natural gas to build up bottom hole pressures to enhance oil production. Do you see that there could be a race involved here with trying to find the right answers, and that CO2 could possibly be even pushed out as a possibility for EOR?
I think that's a good one for Wes. Just start by saying that they are looking at natural gas to help pump it back in and help maintain that pressure. And some of the work that they've done has shown that it can help with that solvency, but there still is a need for, in terms of the massive amounts of opportunity, there's a need for CO2 regardless of what happens with the natural gas. Is that correct, Wes?
Thanks, Mike. Yep. Yeah, what Mike said.
That's an interesting concept, though, the whole notion that we put natural gas back in the ground. Having lived through the 70s and the 80s where I can remember we built a house and there was natural gas at the street, but we weren't allowed to hook up because they would accept no new natural gas hookups because natural gas was in such short supply and it was going away. It wasn't going to be available to us. So it's interesting to contrast that experience. Here I am, 30-some years later, and we're talking about putting the natural gas back in the ground, where it can do more good than in the pipeline. So
I think the economics then will come into play. I think you'd be better off selling your natural gas where it can be used someplace else and then using CO2 to do your formation sweeps.
It does speak a little bit to the challenge of development out in the Bakken, how rapidly, the drivers exist there to step it up, because you do find that we get oversupplied in natural gas in that region pretty quickly. The oil prices and the demand for oil kind of drive the production many times. And so it's interesting that you have those kind of fits and starts, but I think Wes makes a good point. If you look at it over the long term, I think you'll get a different answer than using natural gas.
Yeah, we got a lot to learn there still, Wes. The estimate's still somewhere in the 4 to 7% of the oil in place is about what's being produced.
From the Bakken, right?
Yeah.
So there's 93% that hasn't been touched. We'll never get all of it, but our goal is to see if we can get another 1 or 2%. And 1 or 2% of a really big number is still a really big number.
Yeah. Well, please join me in showing your appreciation for all the panelists, and then come up and ask them more questions.